What is going on, guys? Welcome to the fifth video in learning Java. My name is QD Azdani and you guys watching my channel Kroiwood. Alright, so in this video we're gonna start compilers and interpreters. Now that we know what is platform independency and what is platform independency, we have to understand the compilation and interpretation. Machine language and assembly language are low-level programming languages. C, C++, Ruby, Python, and Java are high-level programming languages. Before running programs, high-level languages have to be translated into low-level languages. We call it machine language. It is much easier to write source code for high-level languages, easy to read and portable as compared to low-level languages, as we said, harder to read and not portable like assembly language. As we said in earlier that if you are writing say a program in assembly language, say for example in PlayStation 1 or PlayStation 2, it is very hard for you all to come and start writing the same assembly language or run your assembly language on say PlayStation 3. Or say in case of Nintendo, if you write your assembly language for the Nintendo architecture, for example 1, you cannot put the same assembly language on architecture, say for example 16. Why? Because once you write your assembly language, say for example if the Nintendo is 4-bit or if it's 8-bit or 16-bit, then what happens, Nintendo is gonna put more chips, more transistors into chips and make it more sophisticated, and instead of 16-bit it's gonna expand, they're gonna expand it to 32-bit. So a 16-bit language, there is 16-bit architecture is very impossible for you. So if your written language is in for 16-bit architecture, there is no way you're gonna put it on 32-bit or 64-bit architecture. You have to write brand new again because all the register is different. Say for example if it's A, B, C, D, E, F, then if it's for 16-bit, then the 32-bit is gonna increase one more. Say for example X, AX, BX, CX, as the case for the 8-bit, 16-bit, say for example in Intel computers, then it's gonna be, for example, in 32-bit computers, they have increased say for example X, AX, BX, because the architecture of the 16-bit and 32-bit is totally different. Then we came into 64-bit, then Intel has to increase one more, say for example ASX or AXX or ABX or something like that. So when we read machine language or assembly language for 16-bit, say for example if you guys dealing A, B, C, D, E, F, then 16 bits, then you guys gonna deal with the AX or BX, then 64-bit is gonna be ASX or AXX or something like that. So it's gonna be 3 digits. As we already know, we have a very good understanding of what is platform dependency and platform independency, and we have very good knowledge of low-level programming languages such as machine language and assembly language. And we also have a very good knowledge of the C++, C and C++, because we have explored the preprocessor, we have explored the object file, and we have explored the linker, and we have explored how the C++ handles the source code from all the way from compilation, preprocessor, compilation, all the way to linker, and all the way to the low level say for example machine language. And as we said that C, C++, Ruby, Python, and Java are high-level programming languages. So before running your program, high-level languages has to be translated into low-level languages. As we said that in the old times, in the 1950s and 55s and 60s, the computer used to hold the whole entire hall or entire room, and ladies and all these workers, they kind of come in and flips ones and zeros, and people actually, they call computers, the company then advertised jobs as a computer, so for the people, for mathematicians to come and do compute, say for example for NASA. And then the guys can turn up and start building assembly language, because it's mnemonics. It's a lot easier English words instead of flipping zeros and ones, because it's very very hard to understand. And once the assembly language came in, then the programmers, they say, why not we're gonna come and start making another language called A. Then A was a lot easier than assembly language. Then the programmers, they start making B language. So the B language is even easier than A languages. Then and another computer scientist came along and created C. So C is the combination of A languages and B languages, and algo language. And that was a lot easier, more robust, and had a lot of features than assembly language and other programming. A language and B language was lacking. Then another computer scientist came in and he created C++. So C++ is a one step ahead of C, and he called his language C classes. So C++ brought a revolution into the computer industry because it has object-oriented features. So, and it revolves around real-world objects. Say, for example, in order for us to tell the computer this is a dog or this is a cat, we as a humans, we already know, we have a sense. And because we as a child, our parents shown us the objects, our eyes can see objects, we can visualize objects, and we've been taught that this is an object. This object is called a cat, and the cat have a four leg and it's got a tail and it says meow and other features. But how would you tell the computers? Because computers, first to begin with, doesn't have any other senses that are like self-aware. Computers are not self-aware. Computer doesn't have a mom and dad. Computers doesn't, they're not born computer, so they're lacking a lot of things that we do. And then the C++ was a way for just like a real world that we learned from our parents. C++ is exactly the same, works the same. So you tell the computer that this is object-oriented programming. This is a cat, and the cat have a properties, the cat have a attributes, the cat have a methods, the cat have a functions, the cat runs, the cat say meow, and the cat say jumps, whatever. And then now the computers have a perfect idea of what is cat. Next time you ask the computer is going to explain to you what cat is. The computer says the cats, this is the functionality of the cats. Cats run, cats jump, cats they come and sleep, cats walk, cats eat, and cats say meow, and cats got a fur, cats got a four leg, and it's got a tail. Then this is a real world, say for example object-oriented programming. Then came along Java. Java was even better than C++ because Java and Python was written in C++. So that's why it's very compatible with C++. That's what when you see compiler, that's what when you see Java. Java is also compilation language like a C++, and it's interpreted language like a Python, because Python and Java is also interpreted languages. And before running a high level language, you guys need to put it in a low level language. Makes sense, because it needs to go all the way to the down to the machine languages. So it doesn't matter what you guys do, even if you go higher than high level languages. Say for example there is another called fourth generation languages. Everything needs to travel all the way to the machine level languages. Everything, whatever you guys do, because if you guys want to render something on the screen, or if you guys want to do anything, you guys may have to manipulate the zeros and ones, because that's what computers understand. Computers they have no idea what this words means. It means nothing to them. Even computers, they don't know what pictures is. Say the pictures behind here is all made up of bitmap. So bitmap is a sort of the zeros and ones. So for example, if you combine bitmap of zeros and ones, just a few, you can see very blurry. But if you combine thousands of bitmap, you can see a very nice pattern here. So these patterns are made of for example thousands and thousands and millions of bitmaps. Even a very small say for example this side of the screen is x-axis and y-axis, and say for example if your bitmap is say 5,000, you can see a very blurry. But if your bitmap is say for example 50 billion, then you can see a very fine pictures. For computer it doesn't make sense. that this is a photo. This photo means nothing to the computer. The computer is all zeros and ones, and zeros and ones we call these machine languages. So, and it makes sense. It makes a lot. It's much easier to write source codes for high level languages, easy to read and portable because that's in plain English, as compared to the low level languages. It was harder to read and was not portable like assembly languages, because it's very hard for me to say is 0011. Then you guys going to be confused, and if I say it's 2, then you guys say, ah, that was easy, because 2 it makes sense, but not a 00 and 11s. So two kinds of program translate high level languages to low level languages, and the first one is going to be compilers, which we're going to see, and the second one is going to be interpreters, which also we are also going to discuss. So keep in mind, in the programming world there are only two types: if you want to compile your language, or if you want to interpret your languages. It's up to you. Says, as I said, some of these are compiled. See these guys here, C and C plus are compiled languages, but these guys here, Python and Java, are interpreted languages. But in case of Java, it's also compiled languages. Programs written in compiled languages execute more quickly, and programs written in interpreted languages can be easier to develop and debug. So there are two sides in a coin. The programs that written in compiled languages execute more quickly. Say C++ is very fast. It's a lot faster than say, for example, Python. Python, because Python is you can interpret these languages, but C++, say Google, when they tried to come in and first run their program, they thought of the C++. Even though a lot of Google was written in Python, because Python is an interpreted languages, but when it comes to computations, and it comes to machine learning, and when it comes to speed, no one can, no other languages can beat C++. There's no way you can beat C++, because from personal experience, I have tried C++ with the Java, and I have tried C++ with Python, and C++ it goes a lot faster, like you can say it like 700 horsepower compared to 200 horsepower with Python and Java. So you cannot beat this language when it comes to speed and computation, as compared to the, say for example, Python, which is interpreted languages. But there are, as I said, there are two sides in a coin, and programs written in interpreted languages can be easier to develop and debug. So when you write programs, it's a lot harder in C++, because a lot of syntax is very confusing, the structure is very confusing, a lot of things hidden from programmers' eyes, whatever. If it's debugged, then it's going to be nightmare. When compares to Python, which is easily written languages, and it's very easily indented languages, and even Java's a lot easier to write, and a lot are easier to manage, and because it's a totally object-oriented language, it's a lot easier to manage, it's a lot easier to do whatever you guys want. So a lot of programs, say for example Android, when it came in, it was you could write Java program in Android. Till now, even no other language could replace Java in Google's Android. Why? Because Java is a lot easier to write, a lot easier to debug, because it's a very, 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 very clean code, and it's very simple. Exactly the same applies with Python. Python is very easy to understand, easy to write, just like a plain English. That's why the Python is very, very famous, and that's why Python is very, very popular. So a lot of big techs like YouTube, Facebook, Twitter, every other Amazon, they use Python, because Python is very powerful and it's very easy to debug and manage. Say even the doctors, even the engineers, even the peoples in say they have no programming experience, they know Python. Say for example, when it comes to agriculture, when it comes to environmental science, when it comes to mathematical science, when it comes to engineering, everyone uses Python. Maybe these people who uses Python, they have no idea about the C++, but they know Python, because Python is very, very easy to write. So you can accomplish complex tasks with just a few lines of code. So there is two sides in a coin. You cannot say, for example, if there is a speed, then it's very hard to manage and debug. Then these guys here there's no speed, but it's very easy to develop and debug. Now we're going to see the interpreters. An interpreter is more like a human interpreter who translates the language at the United Nations from one language to another at the same time that the speech is being given. Just like a normal interpreter, if you don't know, the interpreter means translator. Say for example, if a president of one country, say for example Joe Biden, or Xi Jinping, or any other president, our Australian prime minister, our Indian prime minister, our Pakistan prime minister, our Iranian president, they are speaking at the United Nations General Assembly, which is happening every year. That's got a special session for all the presidents and prime ministers. They talk their agenda, they talk whatever they want to talk, and at the same time there is a translator translating their speech. Say for example, the way as soon as they start talking, the translator jumps in and he starts talking word for word. Say for example, if the president goes 4 words or 5 words, one sentence, then the interpreter quickly comes in and translates that 4 words. Then the president say for example another 6 words, then the translator translates in 6 words. Just if you guys seen that in Al Jazeera, in CNN, CNBC, or the BBC, when the president talk at the United Nations General Assembly, then the interpreter quickly jumps in and translate the language. Say for example, if President Putin comes in and say something, 4 or 5 words, then the interpreter quickly comes in and translate that one into the, say for example, English. So this is interpreter. You can think this is the simplest example I can give you. A real world that this is very true for interpreter. It's just like a human interpreter who translates a speech at the United Nations from one language to another at the same time that the speech is being given. Interpreter is a program and reads a high level program and executes it. Interpreters reads our source code lines little at a time and executes it. Keep in mind, if you observe here, just remember, interpreters is a program. So interpreters, no magical things, or you think that it's like a compiler. No, the compiler also compiles interpreter. So the interpreter sits on the top of compiler. So don't think that the interpreters are some of say for example it's inside the computers, inside assembly language. No, it's a software and reads a high level high level program and executes it. Just like say for example just like a United Nations General Assembly, that a human comes in and starts translating as speech is being given. Interpreter works the same. So interpreters comes in and they reads high level programming languages and reads the source code lines line by line, and quickly as soon as possible they translate it. It's not going to wait for the entire, so the guy finishes the entire speech, then it starts translate. It's not going to do that. As soon as you guys put it hello world, it's going to translate hello world. As soon as you guys going to say hi, this is Cryowood, and it's going to come in to translate Cryowood. Hi, this is going to try Cryowood, and you guys going to put a 2 plus 2, and it's going to come in 2 plus 2. And if you put a 4, if you perform some sort of mathematical operation, then it's going to give you the results straight away. So that's an interpreter. That's why interpreters are easy to manage. Knowledge about the target machine is not necessary, since an interpreter executes the code. It is platform independent, because interpreter is a software by itself. It's a program, so they don't want to know the target machine. It's not necessary, since an interpreter executes the code and is a platform independent. We have already seen that what is a platform dependent and independent, and interpreters are platform independent. They are not platform dependent. The same instruction can be analyzed multiple times. Interpreted programs are slower to run, but takes less time to interpret than to compile and run. As we said, when it comes to computation speed, say for example, if you guys doing algorithms or machine learning, and if you guys want to have a massive file or a massive program, and you want to, say for example, run it to compute, because sometimes you need a very fast computation, then you can go for a compiler. If you don't want that, and if you say, all right, I don't want to go at speed, but I want to go for debug and very good code reusability and manageability, then you guys gonna go for interpreter. Then because interpreters, the codes are very easy to manage. Say you have a source code, and now you are gonna press run, and if you want to run your source code, then the interpreter jumps in, then you're gonna get output straight away. So if from from your source code, then when you press run, then the interpreter jumps in because it's a software and give output straight away. Just like as I said, the UN General Assembly, when someone talks, president or prime minister talks, it gives output straight away. They're not going to wait for anything else, because these guys think of these guys as president, and these guys are people who are listening, and this guy's quickly comes in, this guy's interpreter, and is translated as the speech is being given live. So as we say here now, the compilers, if you want to be expert in Java, you need to understand the interpreters, which we already explained, and the final ones, you need to understand the compilers, how the compiler work. Why? Because Java is an interpreted language and a compiled language, so Java has the goodness of the both worlds, and that's why Java is very popular. In the simplest terms, a compiler is like a human translator who translates an entire book from one language to another, producing a new book in the second language. So as we said, that the interpreters are like a human interpreters at the United Nations General Assembly, and as this president or prime minister of one country gives a speech, and interpreter translates that in real time, word for word, maybe four words. Say for example, if the president says something in 4 words, then the interpreter translates 4 words. But the compiler works totally different. It's like a human translator who translates an entire book. Compilers work in translates the entire book from one language to another in the second languages, and then again it's gonna give you. So once you compiled, it means that it's gonna run the entire book. They're not going to wait for you to come in and says, all right, 4 words, I'm going to translate for you. No, they're going to go for thousands of and millions of code, translate it straight away, gives you a new book straight away. Then they're going to tell you, this is your new book. You can do whatever now you want with this one. I've done my job. That's what the compilers is. Compiler reads the entire program and translates it before the program starts running. Implementing a compiler requires knowledge about the target machine. Each instruction is translated only once. Compiler programs are faster to run, but no platform independence. Compiled languages examples, we have a Java, C++, Swift, and C#. Say now the compiler reads entire program and translate it before the program even starts running. So that's what that's the job of the compilers. Implementing compiler requires knowledge about the target machine. So if you want to, say for example, implement your compiler, you need to know, for example, if it's Intel, what sort of Intel is that, what sort of architecture, whether it's a dual core or single core or i5 or i7, because you need to know the target machine. You need to know where your compiler is going to run, which architectures your compiler is going to run. If it's i5 or because the Intel i5, our i3 is different to i5 is different to i7. So all of these architectures are totally different because they have a different registry. Each instruction is translated only once, not again and again as like an interpreter which translated in the United Nations. This is going to do only once, and you're going to say, that's it, I've done my job. Same like if you want to go online, and if you have a TXT book and you want to translate it to, and you want to convert it or translate it into, for example, another one, say for example PDF, you only, once you press the button, if your book has a 4,000 pages, it's gonna convert it to 4,000 pages and says there it is. But that's just example. But that's what the compilers they do only once. They don't do it again and again. Compiling language examples are Java, C++, Swift, and C#. You can read this as C#. So as we seen in the previous slide, that the interpreter, in the case of interpreter, we mentioned Java, And now in the case of compilers, we mentioned Java. Keep in mind, Java is a compiled language and Java is interpreted language. So now we have here our code that travels. That's our source code. It travels as Java C. We compile it, then it goes to the hello.class, and finally Java hello. Then we're gonna see hello. So that's our source code, which we say we're gonna write a nice program, and we say public static void, and we're gonna output, we wanna put our source code like to output hello.java, and we name it hello.java because that's our source code. And we're looking for a top menu, and we find run, we press run, and the compiler jumps in because we want to compile our languages. And compiler turns our code to bytecode. So our code travels from here, from A, we put it our program source code hello.java, we run, then the compiler is going to say Java C hello.java. Keep in mind, this is that's how you guys compile. Java means Java compile my language, compile this source code hello.java, and here then compiler turns your code into the bytecode, and the bytecode becomes hello.class, just like we've seen in our earliest videos about the C and C++, about the preprocessor, and about the object files, and about the linker. That's exactly is true with Java. So with the Java, when it comes to compilation, the source code, then we run, it goes to compiler Java C hello.java, then it converts it into the bytecode, which is hello.class, and here it is. Then the bytecode goes to the interpreter, and finally it goes to the output. But this is very quick. This is as you guys gonna think this is more more process, but you're wrong, because the algorithms for this one is a lot faster than you even can even imagine. It goes in fractions of microseconds. So when you write your hello.java, when you run, it goes straight away like a bullet. It goes like a light. It goes boom, it's done. So the compiler translated Java C hello.java, then it turns into the bytecode, then it becomes to hello.class, and then the interpreter jumps in, and this gives you that Java hello, then it's going to output on the screen. So that's what the compilers that's the job of the compilers. And as you're going to see in the previous slide, you've seen only one interpreter, but now you're going to see 1, 2, 3, 4, 5, and 6, and you might be thinking this is a lengthy process. You're wrong. This is a very quick process when it comes to Java, and that's what the Java is very popular, because Java has both the goodness of the compiling and interpreting. So the one good thing about Java is a platform independent. It doesn't require, it doesn't matter if you're holding Linux or if you're holding anything, Java just runs on any platform. And that's what, because Java is so popular, because you can do anything with the Java. You don't have to worry about the platform, you don't have to worry about anything. You just, if you want to write game, you just write game. Your game runs on Apple, your games will gonna run on Linux, your game's gonna be running on Windows without worry. So this is the compilers, and this is the interpreters. That's how what happens behind the scene. And in the future videos we're going to discuss these ones too, because as we go we advance in learning Java, you guys are going to get familiar with the bytecode. Especially with the bytecode, you're going to hear this word a lot, and especially with the compilers, you guys are going to hear this word a lot too. And interpreter, you guys are going to hear this a lot. So throughout our program, you're going to see that everything, whatever we write, is going to be the .java. Dot is the extension, Java is extension. So as a programming language, that if you're writing program in C++, then you're going to put a CPP. .cpp. If you want to program in JavaScript, you put a JS. If you want to program in say for example CSS, you're going to put .css. If you want to program in HTML or PHP, you're going to put a .html or .php. That's your extension. So hello.java is your Java is your extension. The compiler needs to know what sort of language is this. If compiler doesn't know this one, it means the compiler can't do anything about your code. So if you put your source code, and if you put a hello and you don't put anything here, then the compiler's got no idea what you're talking about. The compiler needs to know dot, and then needs to know Java, because as soon as the compiler get this one, this is gonna think, okay, this is a Java program, and I'm gonna turn it into bytecode, and it becomes java.hello.class. And this your hello.class travels to the interpreter, and the output is gonna come in as a Java hello. Alright guys, that's it for this video. Thanks for watching, and don't forget to subscribe Crywood. If you guys have any question or comment, leave in the comment box. Otherwise, I'll see you guys in the next video, and bye.